All right, so this last lesson then, all right, it's pretty basic in what we're doing, but tends to be a little bit difficult for some people. Okay, so we're basically going to solve trigonometric equations, but we're going to be using identities to do it. Okay. So this first problem says they want us to solve using double angle identities to solve an interval from 0 to 2 pi. Okay. And we have cosine of 2x plus 5 sine of x equals 3. So here we have an equation with cosine and sine. So the cosine of 2x equals, we have 3 different identities. All right. So we need to get rid of the cosine of 2x. So which identity should I replace it with? One minus 2 sine squared, because I want just sines in my equation so that hopefully I can do some factoring. So we'll have 1 minus 2 sine squared x plus 5 sine of x. And what should I do with that 3? Okay, I want to move that over because I want it equal to 0, because we're going to have a quadratic here, and hopefully we'll be able to factor this quadratic. So we have negative 2 sine squared plus 5 sine of x, and minus 2 equals 0. All right, so what's the problem we have now? Okay, the squared term's negative, right? So we're going to change all the signs. We're going to multiply by negative 1. And then factor, hopefully. All right, so what do I get when I factor this? And if you need to do substitution, think about it. Here we have 2x squared minus 5x plus 2. What do I get when I factor that? What's that? So you need a negative 4 and a negative 1. So when I multiply all right, so that means that both these have to be negative, right? And how do I get 4 and 1? Where does the 1 have to go and where does the 2 have to go? So 2x minus 1 and x minus 2. So here we're going to have 2 sine of x minus 1 and sine of x minus 2 equals 0. You guys all right with that factoring then? Okay. So then that means that either sine of x equals positive 1/2 or sine of x equals 2. So it's 1/2 on our unit circle. All right, and we only care about between 0 and 2 pi. So when does sine equal positive 1/2? Pi over 6 and 5 pi over 6. Okay, when does sine equal 2? What's the largest sine can equal? 1. So sine never equals 2. So there's no solution for that part. All right, that wasn't very magical. So pi over, oh, there it goes. Pi over 6 and 5 pi over 6 would be my answer then. Okay. All right, so get the next one. 8 sine of x cosine of x equals 5. Now, which identity does this look like? Okay, does that look like the sine of 2x? Grant, you agree with that? Okay. Well, the sine of 2x is equal to 2 sine of x cosine of x. Okay. What's wrong with this, though? What's the difference? Okay, this has an 8 instead of a 2, right? Okay. So that means that I could write this as 4 times 2 sine of x cosine of x. So that means I would have 4 times the sine of 2x equals 5. And what should I do now? No, we can't distribute. We're not going to subtract the 5. Right? We want to get the sine part by itself. Okay? All right, we're solving this equation, so we need to divide by 4. Now remember, all this 2 means is that I've compressed it, right? So that we have a horizontal compression, so that that just means that there's going to be twice as many answers from 0 to 2 pi. So all I care about now is, when does sine of whatever, okay, like u, for instance, when does that equal 5/4? Where? At 5 pi over 4? 5 pi over 4, I think sine equals square root of 2 over 2, doesn't it? Okay, negative square root of 2 over 2. Okay, let's see. Inverse sine 5 over 4. What do you think's going to happen? Why? It's greater than 1. Okay. Let's look at the graph. Y equals 8 sine of x cosine of x, when does that equal 5? There's 8 sine of x cosine of x, and there's 5. All right, how many solutions are there? You what? You see one? You see more than I do then. Okay, so here's the graph of it. So there is no solution. You can check your answers with a graph. Okay. You can always type these in your calculator and check your answers. All right. So anytime it's equal to a number larger than 1 or smaller than -1, okay, it's outside the domain or the range, so there's no solution. All right. Number 3, find the exact solutions of 2 sine of x cosine of x, which equals 1/2. Now, let's look at our calculator just for a minute here. Y equals 2 sine of x cosine of x and 0.5. How many answers are there? There are 4 answers. Okay. So we have to find all 4 of those answers. So this is the identity for sine of 2x equals 1/2. Now there are 2 different thought processes for finding this answer. Okay. We could do all possible answers first and work from there. Or since it says 2x, then we could either think of it as just going around the unit circle twice. All right, I'm going to show you both methods then. Okay. Now, so first of all, let's see, when does sine equal positive 1/2? We did that up number 1, right? Okay. So that means that 2x would equal pi over 6 plus 2 pi n, or 5 pi over 6 plus 2 pi n, right? Okay. Now, our answer has to be between 0 and 2 pi. All right? That means that if my denominator is 6, that if I get anything bigger than 12 over 6, it's outside the realm of 2 pi, right? Okay. Now, this is what 2x equals. So then what does x equal? What do I have to do then to make it so that this 2x is now just an x? We have to divide by 2, right? Okay. That means this pi over 6 is going to become pi over 12. Okay, it's pi over 12 because we're dividing by 2 is the same as multiplying by 1/2. Okay? So this would be pi over 12 plus pi n and 5 pi over 12 plus pi n. Okay? Now, so let's think about all the possible answers it could be. So we have pi over 12 would be the first one. Now, if I add pi to pi over 12, what do I get? What's the common denominator there? Twelve is, right? So that would be like adding 12 over 12 pi, correct? Okay, so if I have 1 plus 12, I get, so 13 pi over 12 would be the next one. And then if I add 12 more, I would get 25 pi over 12. If I add 12 more, I would get 37 pi over 12, and so on, right? Dot, dot, dot. The 5 pi over 12, then when I would have 17 pi over 12, because I'm just adding 12 to the numerator. Okay? And then 29, and 41, and so on, right? Okay. Now, the question is, which one of these then are between 0 and 2 pi? Well, if 12 is my denominator, what's my numerator for 2 pi? 24 is, right? So any of them that are bigger than 24 are outside of that area, aren't they? So my answers here are going to be whoa, hey, look at that. Just those 4 numbers there. Because the rest of them are bigger than 2 pi. Okay, so that's one process of doing this, finding those answers. So these are my answers for this problem. All right. Now let's check that out. We already typed in our calculator, right? So let's check to see if that is, our calculator agrees with that. First answer is pi over 12. So let's hit trace and pi over 12. Okay, equals a half. Great, that works. Are you writing on the table? Erase it. Okay, next one is 13 pi over 12. Okay, that equals 0.5. All right, so those work. All right, and the other two will also. So there's one method for doing this. The method of looking at all possible answers, okay, and then seeing which ones work. Okay? That's one way you can do it. All right. Now the other way you can do it is this. And it's very similar. So if we take that 2x equals pi over 6, all right, and 5 pi over 6. Now, if on the unit circle, I have pi over 6, I have the answer, right? Pi over 6. If I go around again, okay, where am I at? No, 7 pi over 6 is over here. How'd you get 13? Okay. All right, because if I go around again, I'm adding 2 pi, right? 12 pi over 6. Right? So this would be 13 pi over 6. Right? And if I kept going around, I would continue to add 12 again, right? Just like we did up there. Okay? So if I added 12 here, I'd add 17 pi over 6. Now, if this number here is a 2, then you can think of it as needing to go around twice. Okay? If it was a 3, I would go around 3 times. So just like up here, that if this number I had here, if this was a 3, then I would end up using 3 of these numbers. Okay? If it was a 4, I'd end up using 4 of these numbers. So you can do it either way. Think of it as going around the circle twice, okay, or 3 times or 4 times, depending on what that number is, and then just taking those numbers and dividing everything by 2. So we would get pi over 12, 13 pi over 12, 5 pi over 12, and 17 pi over 12. Okay, so whether you want to do it as, think of it as all the possible answers there could be, okay, and then find them, or you want to limit it to going around the unit circle so many times and then selecting those answers. It's up to you. But because of the compression, okay, because of that 2x, I've compressed it so that the cycle for sine occurs twice in 2 pi instead of once. So that means I need to think about it as happening 2 times, going through the whole process twice. If it was a 3x, then I would have 3 cycles of sine from 0 to 2 pi, and I would need to go through it 3 times. Does that make sense? A little bit? 0. Ben, you awake this morning? What about Grant? Is he awake? All right. Is he okay with that, Grant? All right. Okay. All right. Using addition identities. We're still working between 0 and 2 pi. Now, let's go back here for a second, this number 3. Now, if they ask us just to find all possible solutions, then this would have been our answer. Okay? If they want all possible solutions, then these 2 would have been our answer. We'd have been done there. But since they only wanted them between 0 and 2 pi, then we had to narrow it down. Okay, so cosine of 2x, cosine of x, minus sine of 2x, sine of x equals -1. So what identity is this? The addition identity for cosine. Very good. Okay. So this is the cosine of 2x plus x. And 2x plus x is? So where does cosine equal -1 on the unit circle? Over here at pi, right? So 3x equals pi. So if I go around again, because it's 3x, I need to go around 3 times. Right? So if I'm at pi and I go all the way around, I'm going to be where then? What's pi plus 2 pi? What's 1 plus 2? 3. Good. All right. All right. Got all the way to precalculus to be able to add 1 and 2. All right. And if I add 2 more, I get? Excellent. All right. Now, just for the heck of it, if I kept going around, I would end up with these numbers, right? The odd pies. Okay. So then if I start dividing them all by 3, then we would end up that x equals pi over 3, pi, 5 pi over 3, 7 pi over 3, 9 pi over 3, which is 3 pi, right? And so on. Now the thing is, we want our answer between 0 and 2 pi. Now, is pi over 3 between 0 and 2 pi? How about pi? Okay, 5 pi over 3? How about 7 pi over 3? Great, why not? All right, what's 2 pi with 3 as a denominator? Okay, 6 pi over 3. So if the number is bigger than 6, then it doesn't work. So I need to get rid of all those ones bigger than 6. And here is my answer. Okay. That's not so hard, is it? All right, one more. All right. We use a half angle identity. Find the solutions of sine of x equals cosine of x over 2, where x is between 0 and 2 pi. Okay. So we need to have these in terms of hopefully the same variable, right? All right, let's play around for a second. Let's graph it. See what we get. Sine of x and cosine of x divided by 2. And our window's already between 0 and 2 pi, right? So we can graph it. Let's see what happens. Okay, there's sine. And here's the half angle for cosine. Oh, so we got a bunch of solutions there, don't we? Okay. All right. Now, sine of x equals, and what's the half angle for cosine? Square root of 1 plus cosine of x over 2, right? Okay. Now, there's two problems here. Okay. Chris, what are the two problems? Do you know? Or just with our equation here, there's two issues. What are the two issues? What's one of them? Now, without trying to change anything, okay, what are the, when you look at it, it's like, okay, I don't like this and I don't like this. What are they? What's one of them? You know? No. Okay, Brandy, what do you think might be one of the problems that I have with what it is? Okay, the square root. Okay, the square root is an issue. Okay, I don't like square roots in equations. They're a problem. Okay, unless I'm finishing, right? Okay, all right, good. What's another problem then? Grant, what do you think might be the other problem that we have? Yeah, we can get rid of that. It's easy enough, though, okay, because that's a normal equation thing, okay? But there's one other problem up here that we don't like when we're trying to solve equations. Anybody know what the other one is? Michaela? There's cosine and sine, okay? There's the two things. We don't want the radical, and we don't want cosine and sine. We want to have the same function, okay, and no radicals. So what should I do then? What's the first thing I could do to eliminate this problem? Or either of those problems? Can I change sine to something with cosine? Or cosine to something with sine? Only if they're squared, right? because then you can use a Pythagorean identity. Okay? So I can't do anything with m. Can I do something with a radical? Yeah, I can get rid of it by squaring both sides, and that's what I'm going to do. Because now then, this will give me sine squared, which I'll be able to change to cosine squared. Okay. So sine squared is equal to what? 1 minus cosine squared. Okay, so now that 2 is a problem because we need to get rid of it. So we'll multiply by 2. All right. And now since we have a quadratic equation, we want to get everything on the same side, equal to 0. So I'm going to move everything to the right because I want my cosine squared to be positive. All right. Can we factor this now? It's actually pretty easy to factor, considering we only have 1 and a 2. All right, very small numbers, that's a bonus. We want this part to be positive 2 and this to be negative 1, so I have a positive 1. So we get cosine of x equals 1/2, and cosine of x equals negative 1. So then we just need to find out when that's true, between 0 and 2 pi. And now our unit circle, cosine is negative 1/2, or positive 1/2 here and here, and it's negative 1 over there. So pi over 3, 5 pi over 3, and pi would be our answers.